Hello everyone, welcome back to ANR Academy. This is Nepaledi Sir. Today we are going to discuss Jensens inequality, and with the help of Jensens inequality you can prove this result. If ABC is an acute angle triangle, show that cos A plus cos B plus cos C, which is less than or equal to 3 by 2. Let us discuss Jensens inequality first, and then we go for solving cos A plus cos B plus cos C less than or equal to 3 by 2 whenever ABC are acute angle. See the statement here. F of x is twice differentiable on closed boundary A to B is given, and its double derivative should be less than 0 for all A less than x less than B. Then for every positive integer m and for all points x1, x2, x3 and so on xm on the closed boundary A comma B, given that Jensens inequality f of x1 plus x2 plus x3 and so on xm by m, that is always greater than or equal to f of x1 plus f of x2 plus and so on f of xm whole divided by m. See the statement. Given f of x is twice differentiable on closed A comma B, and also given its double derivative less than 0. Double derivative less than 0, the meaning here, the function f of x on the boundary that is concave down, the meaning. Suppose if you have double derivative less than 0, the function concave down on the given boundary. If suppose f double dash more than 0, then concave up. F double dash more than 0, we say that concave up. Okay. Whenever f double dash x less than 0, this is Jensens inequality. Here inside the function you have average of x1, x2, x3 and so on xm, and corresponding outputs of x1, x2, x3 and so on xm, you have f of x1, f of x2 and so on f of xm. Their average you have in the right hand side, and the relation between them, function of average of those elements which is greater than or equal to average of its outputs. Equality holds whenever x1 equal to x2 equal to x3 equal to xm. Remember, here if double derivative less than 0, then here the inequality you have to remember greater than or equal symbol. In case in the statement if you have double derivative more than 0, remember that here you have to write less than or equal to notation. Let us discuss with simple points x1 and x2. There are m points x1, x2, x3 and so on xm, but now I am going to explain the same inequality with just 2 points. See here the statement, f of x1 plus x2 divided by 2 greater than f of x1 plus f of x2 by 2. Equality here, equality holds whenever x1 equal to x2. So here I can write the condition x1 not x2, so that only you will get inequality more than symbol. And it is must, its double derivative should be less than 0. That is, graph should be concave down. If the function satisfying this condition x1 not x2 and it is concave down, then this is the relation. Let us observe a function I am going to select which is concave down on Cartesian coordinate system. Assume that here it is x1 and somewhere it is x2. Here x1 and it is x2. Corresponding output, here you will get f of x1. Its output, here it is f of x2. Now I am going to find x1 plus x2 divided by 2, average of these two. Average of these two, that is middle point. Here we get the value of x1 plus x2 by 2. It is of height f of x1 and the point is denoted by x1 comma f of x1, and here this is the point denoted by x2 comma f of x2. These are coordinates of these 2 points. Now I am going to join these 2 points. Suppose that this is some A and this is another point B. Now f of x1 plus x2 by 2. Whenever inputs are x1, x2, their corresponding outputs automatically f of x1, f of x2. When the input is x1 plus x2 by 2, its corresponding output on the function, that is, we get here its height, input x1 plus x2 divided by 2, and its height f of x1 plus x2, f of x1 plus x2 by 2, bracket close. Next, let us observe, you have x1 plus x2 by 2 and f of x1 plus f of x2 by 2 also is there. Average of their heights, this is f of x1 and this is f of x2. I am going to find middle point of these two. Formula x1 plus x2 by 2, y1 plus y2 by 2. y1 nothing but corresponding heights, so that here it is f of x1 plus f of x2 whole divided by 2. These are coordinates of middle point of AB. And now observe the height of the point M. This height is clearly f of x1 plus f of x2 whole divided by 2. And here, since its y coordinate f of x1 plus x2 by 2, that can be expressed as, this is of height at the same point x1 plus x2 by 2, the height on the function, the point, so that f of x1 plus x2 divided by 2. Let us observe the relation between these two. This is more height compared to this. So from these two I can write f of x1 plus x2 by 2, which is greater compared with f of x1 plus f of x2 whole divided by 2. So geometrically it is very clear that f of x1 plus x2 by 2 is more compared to f of x1 plus f of x2 whole divided by 2. Now let us see the proof of cos A plus cos B plus cos C less than or equal to 3 by 2 whenever A, B, C are acute. Why? Because the triangle is given acute angle triangle. If the triangle is acute angle, then I can say that angle A, angle B as well as angle C. Clearly they belongs to 0 to pi by 2. First quadrant, acute angles. And sum of internal angles of a triangle, we know that a plus b plus c, that is 180 degrees, or it is pi. Our aim is to find cos a plus cos b plus cos c, which is less than or equal to 3 by 2. See this figure. x1, x2, x3. Suppose that a, b, c. They are acute. Why? Because less than, in between 0 to pi by 2. Both x1, x2, x3. Suppose angle A equal to x1, angle B equal to x2, angle C, it is equal to x3. And all the three belongs to 0 to pi by 2. That is acute. Now, join corresponding outputs f of x1, f of x2, f of x3. We get 3 points. Here x1 f of x1 1 point, x2 f of x2 another point, x3 f of x3 another point. Assume that it is P and this is the point Q, third vertex suppose R. Average of x1, x2, x3, that is x1 plus x2 plus x3 by 3, somewhere on x-axis I am going to select here. Then corresponding output on the function. Corresponding output on the function, here red colored, so that functional value f of x1 plus x2 plus x3 by 3. Next, observe centroid. Centroid of the triangle, you know the formula x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. y1 plus y2 plus y3 by 3, clearly f of x1 plus f of x2 plus f of x3 divided by 3. Here it is Q, and assume that output of x1 plus x2 plus x3 by 3, this is some H, this one, and here it is G. Compared to G, the point H having more height. This is up to H. This is the height of the function, height of the point G. Y coordinate of G, which is less compared to y coordinate of this point H. So here this is clearly y coordinate of H, this one, and this is y coordinate of centroid. Clearly GY is less compared to HY. I can write GY is less or equal to HY. Equality holds when ABC are same. Centroid y coordinate y1 plus y2 plus y3 by 3 can be written as f of x1 plus f of x2 plus f of x3 divided by 3. It is less than or equal to HY. See the figure, what is HY? That is function of x1 plus x2 plus x3 by 3. Function of x1 plus x2 plus x3 whole divided by 3. And now, since x1, x2, x3 are ABC and function of x here clearly f of x is cos x, so that I can write this as cos A plus cos B plus cos C whole divided by 3, which is less than or equal to f of this is internal part x1 plus x2 plus x3 by 3. Only the internal part you have to write from here to here, right? Yes. x1 plus x2 plus x3 clearly sum of internal angles, that is 180 degrees divided by 3, that is pi by 3. And here the function is cosine function, so I can write cos pi by 3 here. If you simplify this, what we get, observe, cos A plus cos B plus cos C, it is less than or equal to cos 60 degrees value 1 by 2. 1 by 2 multiplied by 3, and hence you will get the result cos A plus cos B plus cos C, which is less than or equal to 3 by 2. Remember, with the help of Jensens inequality, cos A plus cos B plus cos C, we got less than or equal to 3 by 2. Whenever the function f of x is twice differentiable, here cosine function differentiable twice, and double derivative should be less than 0 on the given boundary. In the interval 0 to pi by 2, double derivative less than 0 means the graph should be concave down. Yes, see the figure. You know the cos x graph. Clearly it is concave down in the interval 0 to pi by 2. And also it is twice differentiable. Next, in the statement, if you have x1, x2, x3 and so on xm are the points on closed boundary a comma b, then this is the relation. Function of average of x coordinates greater than or equal to average of y coordinates. In case, remember, in case double derivative more than 0, that is concave up, if the graph on the given boundary, then there is change in the inequality. It should be less than or equal to 0. I hope you understand everything. Thank you so much.